Hello everyone, welcome to AAT Tech Talk. My name is Narala Siddhartha. My roll number is 20951A6744. My branch is Computer Science Engineering with Data Science as specialization. My subject is Database Management Systems. So today my topic is Operational NoSQL Systems, what's new and what's next. So let's start. So I mainly divided the content into three parts. The first part is introduction, the second part is genesis of big data, and the third part is additional distinctive features. So let's start the topic. So first one, introduction, the basic idea about the operational NoSQL. Correct. Introduction. So what is operational NoSQL? Operational NoSQL systems are relatively new in the data management ecosystem, and there is much confusion about their capabilities and how they differ from traditional relational database systems. This summary of characteristics clearly distinguishes the two system classes and provides a glimpse into directions for the future work. As the demand for big data applications escalates, data management systems DMS must provide the infrastructure that will enable applications to achieve new performance and scalability levels. For the past 4 decades, relational database management systems RDBMS have been central to many businesses. However, modern applications require functionality such as schema evolution, heterogeneous data types, and multiple data models that has not been the focus of traditional RDBMS. To address to address these functionality gaps, newer DMS are expected to scale gracefully, automatically, and economically. Graceful scale allows nodes to be added as the data volume increases, therefore maintaining expected per-query performance. A system with so-called automatical scaling automatically balances data to accommodate the additional nodes. Finally, with economical scaling, the operational cost of deploying the system decreases as the hardware improves. Thus, cost reductions from lower computing and storage costs are passed through to the overall cost of DMS deployment and operation. A new class of DMS NoSQL systems exhibit all three of these characteristics, although their name implies the antithesis of SQL. These systems encompass several varieties, including not only SQL. Their goal is to expand, not necessarily replace the design parameters embodied in existing RDBMS. NoSQL classes. In the world of relational database management systems RDBMS, data processing systems are generally either online transaction processing OLTP systems or decision support systems DSS. OLTP workloads largely consist of short queries that need to read or write a small number of tuples or records in a database. An OLTP workload might be order entry, in which the database system records new orders and pulls up existing ones. In contrast, DSS workloads consist of complex queries that generally involve scanning, joining, and aggregating over one or more large tables in the database. For example, sales trend analysis is typically done in a DSS engine. Analogy NoSQL systems have two main classes: operational NoSQL systems, which corresponds to OLTP, and analytical NoSQL systems, which corresponds to DSS. Like OLTP in the relational world, operational NoSQL systems are transactional. Examples include Aerospike, Cassandra, Couchbase, DynamoDB, HBase, MarkLogic, MongoDB, Oracle NoSQL, Redis, and React. In contrast, Analytical NoSQL systems are based on MapReduce, Hadoop, and Spark. Similar to the traditional RDBMS, analytical and operational NoSQL systems have distinct use cases and largely independent markets. Defining features. As the genesis of big data, sidebar describes many salient features of NoSQL systems stem from the demands of big data applications, recurring common core features and additional distinctive features that resonate with customers across a broad range of deployed NoSQL systems. Common core features. Features common to most NoSQL systems include malleable data schemas, flexible querying, operational simplicity, community, and low cost. Malleable schemas. In many modern applications, the data schema often changes. For example, when storing user profile information in an advertisement targeting platform, the number of user attributes changes as new user information is recorded. Flexible querying. Closely related to the use of malleable schemas is application of the flexible database search methods such as free-form queries that rely on regular expressions and queries based on keywords. Operational simplicity. Traditional single node or site data processing systems are notoriously hard to administer and manage, especially when trying to tune query performance as the underlying database grows and the query workload pattern shifts. Moreover, most modern data processing systems are deployed in cluster setting with commodity hardware components, which compounds administration difficulties because mechanisms are needed to deal with component failures in a manner transparent to the end application. So let's discuss about genesis of big data. A brief look at how data processing systems have set to the stage for contemporary NoSQL systems make it easier to understand what drives current and possibly future NoSQL system development. Data processing methods have been at the heart of computing systems since the birth of computer science as an independent field. Computing history is full of vibrant debates about which particular data processing technology, models, and methods are the right ways to manage data. One of these debates centered on the relational database model versus the network data model. From roughly the 1980s to the early 2000s, nearly 3 decades, the relational data model and its implementation in the form of RDBMS dominated both the marketplace and the mindset of database management researchers. However, at the turn of this century, a shift has occurred that went largely unnoticed in the mainstream database community: relational model dominance. In the year leading up to that shift, organizations has to think about what data they would pull into their RDBMS because of the expense to store and analyze it. Costs included database licenses and the hiring of high-priced database administrators. The marketplace was saturated with RDBMS vendors and products became entrenched below deep application stacks, making it hard for an enterprise to move to different RDBMS engine. Vendors fiercely competed in a series of benchmark works that fixed performance gaps and largely ensured that database products generally provided the same functionality and performance. Re-elevations that started the movement. Questions about alternatives to the RDBMS approach started shortly after an imperceptible shift happened when companies like Google and Yahoo realized that storing and analyzing only certain data ran counter to their business models. All data has values. These companies simply could not afford to throw data away, and storing and analyzing large volumes of it was part of their core business value proportions. So let's discuss about additional distinctive features. Some operational NoSQL DMS are also characterized by predictable performance and rich data structures. Predictable performance. Many modern data-driven applications care more about performance that is predictable rather than fixed at a specific level, particularly when they must scale to large datasets. When designing this kind of application, it is far more convenient for the designer to budget a set amount of time to service the queries that are sent to the database layer. Rich data structures. Traditional database systems have worried about the impedance mismatch between the data types in the data model and the application programming environment. Understanding the unique characteristics of NoSQL systems, how they have evolved, and where they are headed can help identify open problems and stimulate communities to engage in solving them. With researchers willing to look at the challenges associated with the deciding, developing, and deploying these systems, the awareness of their capabilities and promise will grow, and eventually commercial offerings will expand. Thank you.